And so you turn the power switch off, and then you grab the chuck with your hand, and your hand is a friction brake on the chuck. See people do it all the time. Not here, hopefully. So you can do that. Kind of. It's a bad idea, because what if there was a burr on the motor? It's going to just swing your hand right wide open, right? But, yeah, the real presses that we have in the shop here don't have belts, they have gearboxes. And, you know, like 400 or 500 foot-pounds of torque also. You don't want to be trying to stop those with your hand. So yeah, you could either on purpose or inadvertently grab the chuck of the lathe or the spinning part of the lathe. How else could we die?
If a grizzly bear got loose in the lab.
You know,
I go through many people.
my aunt has had a grizzly bear in her living room. Came right through the screen door, didn't slow it down at all.
Curtains.
Certain parts could fly out and.
Yeah, what's your name again? Kirsten? Kirsten wanted to get cut and, well, thought that the carotid artery could become cut by a. I just typed drive.google.com in the thing here, but I missed the E at the end of Google and Bing search for it instead of knowing what I meant. So you suggested we could get cut by a piece of material that gets thrown out of a machine. Blood force trauma could do it also, right? Right? So a heavy piece of material could hit us. Don't worry about that. Most force.
Fall down the stairs.
You can fall down the stairs. I hope you did that outside the shop, but yeah, you can do it on the way to ME1800, on the way from ME1800.
I didn't like it down, but maybe a stray bullet could come through the window and hit you.
Could do it.
Trick shot.
I should come and listen to this.
Yeah, so let's think about things that we typically see happen during labs that could kill us.
The bear's likely.
What's things that we do in lab? So we got blood force trauma from a part coming free. We got get cut by a part coming free. Go.
There was like a rainstorm and it shorted out one of the.
Oh, so we got other hazards besides flying parts, right? We have electrical hazards in the lab. So you know Washburn's the second oldest building on campus? Yeah. It was a few years ago they redid the roof for the whole building in Washburn. While they redo roof, so I mean they were redoing the roof because it already leaked a lot. But while they redo a roof, the first thing they do is take off the old roof, and then you get thunderstorms and rainstorms and stuff like that, right? You also have wet labs on the 3rd floor in Washburn, where if the drain is plugged up and they're running water for cooling, it comes out underneath. Comes out onto the floor, and you get like forces of water on the floor of the lab on the 3rd floor. That water goes somewhere. So I walked into Washburn 108, so that's the room where the VM2 is, where all the robots are. I walked into that room, and noticed a script, and looked up, and saw that the water that I could see was coming out of the 480 volt 3-phase 60 amp bus duct. So we had a thing that was intended to carry cables, that was carrying cables and water, and it was energized, and it was 480 volts, 3-phase, 60 amps. I pressed the room stop and shut that off. That was from the lab still upstairs. So yeah, water and electricity don't mix
Well,
up.
shutting it off may have been the right thing to do. I'm not sure that simply gripping on it would have completed it.
No, but it was probably a bad idea to have that full of water and energized. Yeah. Because it could cause fire. So you could catch fire. The first time I learned that I could log into MyWPI from my cell phone was because I had to email the class to tell them that there would be no lab that afternoon due to the fire. Same roofing project, the roofers caught the building on fire. So fire wasn't in our lab.
improper use of the pressurized air could give you an infection.
Ah, so you could cut yourself, get an infection because, well, the, I don't know, you guys ever see that coolant in the machine tools? It's pretty nasty stuff. So, yeah, so infection is a problem. I would hope that you seek medical treatment before that kills you. But absolutely. We got fire hazards. We have electrical hazards. We have flying stuffed hazards. We have getting caught by the machine and entangled in the machine. Now, what's the mechanism of getting killed if you become entangled in the machine? Somebody else. I know Zed's been thinking about this. Somebody else. Chicks has been thinking about it too. Open the back.
You can bleed out.
So you can become cut and bleed out. What else? Yes.
It could choke you.
You could suffocate. You could become entangled in the machine and it could choke you.
Well, you like the tide would tighten that.
Yeah, or yeah, it could pull the clothing. But typically, unless somebody acts to stop the rotation, you're going to also get sucked in at that moment too. Who's got hair? I do not. You know, if I get my hair cut on the machine tool, that just goes to show you that I should have had my shirt on when I was in the lab. Right? But people that do have hair, so you can become entangled in a machine with your hair, right? Okay. So there are ways that we can die in a machine shop. How come we don't talk about this on the first day of class? Because when I took this class, we spent the entire first day of class talking about this and looking at pictures of all these different kinds of incidents that have happened. That's when I took the class. We did that, and I suppose the first few semesters that I taught the class, that's how we did it. Because, well, we always do things the way we've always done them, right? Right. So the idea of having that discussion would be to scare you into believing you can follow safe practices. Right? How come I don't do it on the first day of class?
So people don't drop class.
I don't know that anybody ever dropped the class because they didn't like that safety lecture. I mean, I don't know that we've ever kept statistics on it either, but. Yes.
Maybe now people are more comfortable with the tools and the experiments on their own.
So one of the reasons is because when you first walk into the lab, it can be, especially if you have no experience in a facility like this before, it can be pretty intimidating. And when you walk into a situation that's pretty intimidating, you're always on your sort of peak, what's going to happen kind of behavior. So you're actually more mentally alert when you don't know what's going on, because you're paying attention to everything. Now, you don't necessarily know everything that's going to hurt you at that moment. So before we do that first lab, we have you read the safety policies, right? And we have you go through that little bit of an exercise to get familiar with what goes on in the lab. So, all right, so we're now more familiar and therefore more likely to take chances and skip safety steps. That's one of the reasons. Why else? So,
Actually, I was wondering, did you go for you to
no. If you guys want to see pictures like that, just Google it. You can find them. They're all over the internet. When I took this class, there was no internet. Technically, there was DARPANet. But there was no World Wide Web. There was email, sort of. Yeah. Anyway, but now you get all that stuff freely available to you. So, But hey, how do doctors kill people? What's that? Chemicals inside. How is the doctors kill people?
In 1968, at the height of the war in Vietnam, 14,000 Americans were killed and 46,000 were
Typically, they
wounded.
do it one at a time. How do engineers kill people? Engineers can do it by the
That same
thousands,
year,
right?
another 14,000 Americans were killed. But those lives were lost right
So
here in the
did you
United
get
States
those numbers?
because those American men and women were killed at work.
Did you hear those numbers?
Yeah, as many people were killed in work as were.
1968, which is known as the bloodiest part of the Vietnam War. You can watch this like a 45-minute long documentary. Watch the whole thing. We're not going to do that now. 1969 or 68 was the bloodiest year of the Vietnam War. More people were killed in industrial accidents in the United States than U.S. soldiers were killed in Vietnam.
Americans is exposed to expect it's the law that men and women were killed at work, on the job. Another 2.5 million American workers suffered disabling injuries. That's 54 times the number of people we had wounded in Vietnam that year.
The subcommittee will be in order. This morning, we're continuing with our oversight hearings to the occupational safety and health.
In an effort.
All right, so as a result of those numbers, there was a big push in Congress, starting in the late 1960s. It was in 1971 that they actually founded this group called OSHA. If you want to see some really good bloody pictures, you can watch some of the OSHA commercials on YouTube. This group called OSHA, Occupational Safety Health Administration. It says what it means.
I thought it was operational safety.
No, yeah, occupational, definitely occupational. The O is occupation. So OSHA is the federal. Anybody had any interactions with OSHA ever? Talk about your interaction, Aiden.
I had to do official OSHA training before I was allowed to go onto the lab floor at my internship lesson.
So did you do a whole 10-hour OSHA?
Yeah,
General industry certificate?
it wasn't with any representatives from them.
It was an online
It
class.
was like the online class
Yeah.
and everything.
There's several of these online classes. It's actually interesting. These OSHA classes, they're based on the time that you spend in the class, not based on testing whether or not you've learned anything. All of them. So there are 10-hour construction OSHA classes, 10-hour general industry OSHA classes. There are 30-hour classes, and so on. And what they talk about, they talk about rules and regulations. So what's the law? What do you, as the employer, what do you have to do as the worker? What are you responsible for? Somebody else raised their hand on interactions with OSHA. So you've had an OSHA 10-hour class.
It was, I don't think it was 10 hours.
Okay, but you had an OSHA class.
Yeah, I had an OSHA class.
Who else? Somebody else over here. Yes.
I had an OSHA class and then also compiled like required documents for OSHA, like
So you had a job where you were actually helping maintain the facility's compliance with OSHA regulations. You also?
Yeah, I had an online training. It was like through the company, but it wasn't 10 hours.
Okay. Nobody in here is a lab monitor in the facility yet? Yeah. So in order to become, so we've got lab monitors that can keep the Rockford Shops facility open after hours. In order to become a lab monitor, one of the requirements is that you've done a 10-hour OSHA class. There's several of them available. All right. So OSHA is a government agency. Its job is, what's the purpose of OSHA? Who had never heard of the term OSHA before today? Anybody? Some of you. Okay. So people that had heard of OSHA before, what's the purpose of OSHA?
Making sure machine shops or facilities are safe.
So you specifically named machine shops and facilities. So OSHA actually has jurisdiction over any place where you're being paid to work. If you are collecting money for doing your work, OSHA has jurisdiction. Yeah.
I was gonna say, just as important.
Right, so the mandate of OSHA is to improve workplace safety so that we don't have, what was it, 400,000, no, 40,000, what's the number? It's like 1.2 million disabling injuries. Yeah. So that's OSHA's mandate. Now, anybody work construction? Summer jobs, anything like that? I used to work construction for summer jobs while I was in high school and then through college. And I remember one job, actually coincidentally was the day that I started that summer job. The OSHA can show up at your workplace unannounced. They just show up and start looking around. That's their job. They can show up because randomly they selected to go show up at your workplace, or they can show up because somebody made a complaint about something unsafe at your workplace. So the OSHA guy shows up and he issues a $10,000 fine before he gets out of his car. Because he looks over his shoulder, and just as he's pulling in the driveway, there's a guy riding up out of a ditch in a backhoe bucket. There were two problems here. One, you don't ride in backhoe buckets. You don't do it if you're at I'm just saying, you don't do it if you're at a place where you're getting paid to do the work.
Why don't you do it in a place where you're getting paid?
So the other problem was though so there's rules about like you can't be in a ditch that's too narrow because if it caves in, they can't get you out. Right? So the ditch was too narrow, and he shouldn't have been riding the backhoe bucket. $10,000 fine before the guy gets out of his car. Do you think he was in a good mood or a bad mood when he inspected the rest of the site? He was certainly looking more closely, right? They will count like how many rungs on a ladder, and if it's above a certain number, it should have been a staircase, not a ladder. They will check to see if you have two extension cords plugged together. You're not allowed to plug two extension cords together. Oh, daisy chains in the back. But when I worked at this construction company, I remember at the same company, different job site, might have been a year later. It didn't scare me off if they were the same. I remember getting a call on the radio. It was the foreman. And he said, the OSHA guy's on site. Knock the handrails off the man basket, so it's just it's an equipment basket now. Because we had a wooden thing that we built that the crane would lift up, and we'd work on the side of the bridge while standing on the wooden thing. It had no rails on it. It was just for carrying equipment, and it was okay. Right? So the employees are complicit now in foiling the OSHA inspection. Is that a good idea?
No.
No, OSHA's there to protect me. I shouldn't try to foil OSHA. Right? What can happen? Anybody know what can happen to people and companies that violate OSHA rules?
They can get fined.
There are fines. There can be significant fines. There's actually an OSHA inspection at WPI 2 weeks ago. We're expecting fines.
They could like shut down your facility temporarily.
They could shut you down permanently. Usually it would be temporarily, but they could shut you down permanently.
How bad would it have to be for them to do it?
It would usually be, well, they can put you in jail. If they told you about it, and then you go back and knowingly violate it, and somebody gets hurt, they will put you in jail. That's a felony.
Is there any one-time thing that can put you in jail?
No, if you absolutely should have known better, then yeah, you don't have to have been warned in advance. They can put you in jail.
Was there anything like that?
Nothing that I personally am associated with. You must report if within 24 hours. Failure to do this is a felony. You must report within 24 hours if anybody dies, or if 5 people go to the hospital for the same incident. You can have 2 different incidents, like 3 and 2, that's okay. 5 people at one incident, you must report within 24 hours, that's a felony. It was funny, I was at a gathering of university administrators, universities, private schools for New England, with safety. They were talking about safety, and the head of OSHA for Massachusetts was there as one of the speakers. And so, who does OSHA protect? Employees, workers. So these are a bunch of school administrators talking to the OSHA guy. And so what do we have at schools? We have workers and we have students. So yeah, you must report it if 5 people go to the hospital. Question comes up. It says, what if it's 2 staff members and 3 students? Do I have to report it? And there was debate. I mean, there's probably 100 school administrators in the room, and they're talking about, oh, you should report, you shouldn't report, you shouldn't. Excuse me, what's the downside of reporting something that you didn't have to report? So what would be the downside of reporting something you didn't have to report? Okay.
Well, I was gonna ask, are the students obligated to report?
No, it's the employer, the supervisor, is obligated to report to OSHA if somebody dies or 5 people in the hospital. You're not. That was a call. 5 minutes silent. What would be the downside of reporting something you didn't have to report?
Get penalized towards the extreme level. More than you think you should have been.
Well, so if I report something, the immediate thing that OSHA is going to do is come do an evaluation, come do an audit, come do an inspection, and try to help figure out the root cause of the incident that caused 5 people to go to the hospital. Right? So that's the first thing that they're going to do. If they find that we were deficient in our practices and policies, it could be that it was just an accident. And it could be that there was no deficient policy and that there was no intent, there was nothing wrong. And they're going to find something wrong. They're going to find something wrong, but they probably won't find it. They don't necessarily find something big that's wrong. But yeah, so if you bring them in, you're probably going to get a fine. If somebody complains, and OSHA comes in and does an inspection, and they find something wrong, which they will because that's their job, right? You're probably going to get a fine. But it's a matter of how you react to that, on how big the fine is. They have some discretion in those fines. All right, so the downside is that we invited OSHA in, we're going to have a fine. What's the upside of inviting them in if we didn't have to?
Maybe something that would have caused.
Maybe they could help us enhance our safety in the long run, right? So I would say err on the side of inviting them in. Actually, I believe that if you as an employee complain that something's unsafe in the facility, and they come in, they will fine you. They will fine the company, not the employee. And it's all anonymous, right? If somebody reports something, it's all anonymous. If I, as the employer, ask the OSHA guy, hey, we just got this new facility, we're getting ready to start using it, or maybe we've already started using it, can you please come in and do a courtesy inspection for me? You just let me know if we're screwing anything up. Then they'll let you know what you're doing, and they'll expect you to fix anything that they note, but they're probably not going to find you because you asked them to help you. All right, so there's different things you can do there. All right, but we're talking today, our lecture today is about the design of safety systems. What is a safety system? So a safety system can include e-stops in the room. Somebody quickly, what's the difference between the e-stop on the wall and the e-stop on the machine?
Stops on the wall, stops all machines.
Does it stop them?
Shuts down the power.
Shuts off the power going to them. The e-stop on the machine, on the CNC machines, all of them, it actually applies a brake and it stops the motion. So if Zeb was the one that wanted to become entangled, right? There was a couple of them up there. Somebody wanted to become entangled, right? If someone's becoming entangled in the spindle, Typically, it's the operation of the rotating spindle that gets us entangled. Which one do you rather hit?
Machine.
One of the machine, because that's going to stop the rotation, right? What if you're halfway across the room? Run. You know, that's hard. You have less than an instant to make the decision. I probably just restop. I don't know. Luckily, I haven't been faced with making that instantaneous decision. But you're better off, if you can, to hit the one on the machine because it'll stop that rotation. Okay, so a safety system can have e-stops. So what's an e-stop going to do? Once the incident has begun, it's going to mitigate the damage, right? Once we've begun to become damaged by the machine, the e-stop is going to help us limit the damage. If we're anticipating that a part may become loose in the machine, if the e-stop before it becomes loose, you may interrupt it before there's any damage. Yeah. What else is part of a safety system?
The doors on
The doors. What else about the doors?
they're designed to resist flying the roof.
All right. So those doors are designed to contain things that may become free inside the machine tool, especially the ones that would cut our carotid artery. Maybe not the blunt force trauma ones, right? Because the blunt force trauma ones have more energy. All right, so the door, you know, all use the lathes, right? Does it have a pane that's a little tiny window that you can see through? You can hardly see what's going on inside the lathe when it's cutting. You know why the window's not bigger? Either one.
Does it move faster than
Same top speed, 6,000 RPM on those ST10s and SL10s and the mini mills.
if it were any bigger, it probably would be able to hold a certain amount.
Yeah, so we like to have steel next to where all the crap's going to go when that chuck flies apart. Just picture 50 pounds at 6,000 RPM and 10 inches. There's some energy there. You need to contain that. All right, so the doors. What else about the doors besides the fact that they will contain stuff if it starts flying around?
Magnetic sensors to
Interlocks.
Yes.
So most automatic operation of those machines will not happen if the door is ajar. If the door is not closed, it won't operate. Actually, on the newest machines, you pretty much can't do anything with the door open. On the older machines, there's a little bit more laxity. I have a friend who owns a company that makes capital equipment. Capital equipment is things like machine tools. This particular thing that they make is thread rolling machines. So you take a rod and you can form the threads on it without having to remove any material. You just compress it all together. They make those kinds of machines. And they've been making them since like the 19-teens, the 1920s. So they have a lot of machines in the field. Turns out back in the day, they built machines to last. So they still get back occasionally a machine to refurbish from 1930, where you need to update the control system, maybe replace some of the worn components. Well, as he said it, in 1930, when a guy lost an arm in the machine, you got another guy. But now when they get one of those machines back, it has to go back to the customer with all of the updated safety standards on it. So there's interlocks, things that stop it from operating with the door open. What else?
Non-machine items like the sleep on the floor, you can use the hazard zone and
So markings. What else is part of our safety system? I'm going to call that don't be for years. Our safety checklist. So I'm going to call that operational procedures. So operational procedures keep us, are all part of our safety systems out.
The machine's ability to sometimes stop up itself if we're in possible problem.
So machine safeguards. And so by that, you mean it could sense that something is wrong and stop. This is beyond just opening the door. The Israelite. So it would be an unstable vibration, and it could stop. Most machines don't do that. But it would be possible.
You gotta wear safety goggles, so it's on the job.
The personal protective equipment and policies governing the use of personal protective equipment. What else is part of our safety system?
The sensors that you see with some of the machines so that if the building technology goes off.
Okay. Why do those exist? We'll get to that. So the scissor things. We'll get to that in just a minute. So this is part of, and so basically what you've been describing is the safety system that we use in the electric shops, right? That was our reference here. Where do we find safety systems besides the machine shop? That.
Basically just anything designed to prevent an accident or hopefully accident.
So where can we find the safety system? Yeah, so that would be like at a construction site, right? So people working at a construction site, or the guys that work like doing the lights for lenses and lights, stuff like that. So that's actually an OSHA rule. If you're more than 6 feet off the ground, and if you're going to be stationary for more than 5 minutes, you have to be harnessed in. If you're more than 6 feet off the ground, you have to have the harness. You have to clip in if you're going to be stationary for more than 5 minutes. That same job where they rode up out of the hole in the backhoe bucket. So I arrived. The other thing that happened the day I arrived was they put the last piece of steel down for the bridge that was going to span the river, the highway bridge. And so we spent most of the entire summer building concrete forms suspended between the pieces of steel so we could pour the concrete bridge down. But we were never still for 5 minutes. So although we all had our safety harnesses on, we were never clipped into anything. And we were within OSHA rules there. So construction sites, where else do we have a safety system? Does the safety system have to be a physical facility? Yeah.
We have it in the chemistry lab.
The safety systems in our chemistry lab that involve many of these same things. We've got our personal protective equipment, we've got operational policies and procedures. We may have other, so anybody ever use a fume hood? Right, that's part of the safety system, right? To keep you from breathing the bad stuff that the birds breathe. Okay, that's where it goes. Through the stack. Where else do we find a safety system? Seatbelts. We find them in cars. Where else do we find safety systems? Yeah, buildings in general have safety systems. So this building has smoke detectors, sprinklers, and handheld fire alarm pull stations, and a centrally monitored fire alarm panel that if any of those activate, actually this one rings through the WPI campus police, and then they call the fire department. Most of them, if you don't have like an on-campus 24/7 monitoring or something like that, it would ring straight through the fire department. If the fire department receives the signal, they must respond. Whether you call them up and say, hey, that was a false alarm, they must show up when they receive that signal. So yeah, what's the purpose of the smoke detectors? So you guys should all have smoke detectors wherever you live, right? You live in an apartment or one of the dorms on campus, there's definitely smoke detectors. What's the purpose of smoke detector?
Like alert occupants of their smoke and what they do.
To save your life. The person who's inside. What's the purpose of the sprinkler? Save the building. Smoke detector saves the occupants. Sprinkler saves the building. It's funny. I used to manage a whole bunch of rental properties, and I wanted to add sprinklers to my buildings because, well, that seemed like a good idea, right? So my insurance company was going to increase my rates if I added fire sprinklers to the building because they were more worried about water damage than they were about fire damage. It may have changed since then. That was back in the 90s. So we find safety systems all around us, right? Pretty much anything we buy. I mean, have you bought anything lately that didn't have a warning on it? Warning labels are part of our safety systems, right?
Plastic spoon.
I bet if you look at the package, you'll find a warning label.
Burger paper.
But most stuff that we buy, right? So why do we need safety systems?
You might not have time to get it up today.
Why do we need safety systems? Yeah, because we're idiots, right? So, anybody know about this incident? This was a senior at Yale. This was the date on here, 2011, 2 years ago. So this happened at 2 o'clock in the morning. She was working in the lab by herself, working on a piece of equipment that she knew how to use. She had used it many, many, many times. Her long hair, became entangled in the spinning spindle. It wrapped her neck around the part. It was a woodworking lathe. It was belt driven. It stalled, just like that drill press. Remember I said you could grab the chuck and you could stop it? So it stalled the belt, but she choked it out. And that's why we have those little scissors by all the machines. And we try to keep them by the machines in such a way that you can reach them if you were ever in a situation like that too. So I knew about this. I mean, so you can imagine universities, especially universities in New England, word travels pretty fast about stuff like this. So I had a phone call at 7 o'clock in the morning. I was driving to work. I was on the phone with the department head. He told me about it. And his first question was, how do we know this can't happen to WPI? And the honest response had to be, well, it could happen at WPI. But we have really good policies. When you think about it, especially had really good policies at Yale too. And it turns out they did. And then when you look up their policies, it was almost exactly identical to our policies. So we had to reevaluate how we know people are obeying the policies. How do we know, it's not actually a policy if you don't enforce it. It's just the pretty words on paper. So we need safety systems because not just people are idiots, people make mistakes. She knew better. All of the things that led to that, she knew better than to do them. But she made a mistake, and mistakes can end us pretty quickly. How do we design safety systems? Yes?
Based on previous accidents.
So one of the things we do is we look at what has happened in the past, and how can we prevent that. So we have that, I wrote this at WPI.edu, right? So we collect all the information from those emails to try to see, can we change our operating procedure to make that incident not happen again? Because although the machine tool contains all the energy from that end mill exploding, what if the window failed, right? So we don't. So those are about safety things. So one thing is you look at past things. What has happened in the past? How else do we design safety systems here? You look at, okay. So we want to anticipate failure mechanism, failure modes. So of all of the things, remember back at the beginning, we asked, how could you possibly die in a machine shop? Or in the ME1800 lab, I said. What do most of those mechanisms have in common? Well, it could have been prevented, but they all did. Right? Forced over distance that causes that incident. What you want to do is you want to say, what are the mechanisms? So we've got fire hazards, right? How do we protect the fire hazards? Remove. Train our operators on how to safely use the things that generate fire. Like that. So list the possible mechanisms. Identify the hazards. You can eliminate a hazard, right? You can interrupt the propagation of the hazard by some protective barrier, so the door, the shields. You can train the operators and warn them, right? These are the ways that we can make safety hazards go away. I will leave you with this thought. And we'll do the little form. And this is the reaction. 29 stitches. Oh, don't get her in the lab. This paperwork I have to do. It's a pain in the butt. Thank you for your attention. Well, this is where she got hurt. The blood was cleaned up. Yeah, I don't